And so the first key feature set wanted to walk through is authentication. Go to do a walkthrough, just kind of like the diagram. This is a rough draft. We'll beautify this over time if necessary. So I'll go through this and then we'll look at some of the code that implements some of this. All right. So from a mobile perspective, right. So we're gonna have application deployed on the mobile phone, and then we're using Google Auth. And there's also going to be Apple Auth. Right now, Google Auth is what's implemented. Soon we're going to be implementing Apple Auth. But so in terms of authentication, I think this is to be helpful for people who might be new to authentication and who might be new to the fact that if you're building an app and you want people to be able to log in, this is what really is going on behind the scenes. So okay, so our app, we're calling Google Auth servers to get an access token from Google Auth servers. In terms of our app, another key thing to note is, so our app is going to be issuing its own tokens, JWT tokens, but we were using Google in terms to leverage the fact that we want to make sure that they have a Gmail, that's actually working and that's actually active and it's already hooked up with Google. And so we can just leverage, that infrastructure versus having to build out that login of username and password tracking on our end. So we're going to get the ID, and it's called an ID token from Google Auth. And the reason why we're getting that ID token is because Google provides a endpoint that allows you to verify that the ID token is actually valid. So the mobile phone, when you're logging in, so the user selects their email, they log in, we get that response from Google. We take that response, which has an ID token. We call our backend, which has a endpoint that takes the ID token. It takes the ID token, it goes and validates with Google to ensure that the ID token that we got is valid. If it is valid, then we produce our own access and refresh JWT token. And we return that to the mobile app, the client, and then the mobile app saves that in secure storage. And again, thinking from a high level, so what's really going on behind the scenes? So we're using Spring Boot. So fortunately, Spring Boot has a lot of machinery that helps us deal with these tokens, in particular the JWT tokens that we're going to be issuing the client once we verify that they've successfully logged in with Google. So yeah, I'll show the code, but there's a security configuration that we set up with Spring Boot, and then so that's where we tell Spring Boot that we want to use tokens, and then we also tell Spring Boot that we want a token every single time there's an API call, and then we're going to validate that, and then Spring Boot is going to help us validate that token based off the based off some beans that we configure. So we're going to configure an encoder, a decoder, and we're going to provide the secret key that Spring Boot should use to encode and decode. And so then so whenever an API request comes in, it goes through our security config, it goes through our chain. Spring Boot ensures that the JWT token is valid, so it's signed properly. Valid essentially means that the access token and the refresh token that we provided the app was not tampered with. And if it's not tampered with and it's valid, then the person can communicate with our backend as necessary. Another thing to call out is when it comes to dealing with tokens, so typically the access token, which is what is used to be able to access the APIs, that has a expiration period. So when it expires, then it cannot be used anymore. And so we do have an endpoint also for a client to get a new access token using the refreshed token that we provide. So if they call that endpoint, they will be able to get a new access token again, as long as the token that they provided is valid.